Okay, so our next topic is all about representing functions, and there's three primary ways we're going to see functions represented in this section. One way is through mapping diagrams, another way is through tables, and then the third way is through graphs. So we're going to take a closer look at each of these examples. Mapping diagrams represent a function if each input value points to only one output value. Now we want to remember that input values are x values and output values are y values. And our key word here is going to be points to in these examples. And then they do not represent a function if an input value is pointing to more than one output value. So if we look at what these look like on the inside, we've got some sets of numbers and some arrows. The first set of numbers that you see are your x values, and the second set are your y values, kind of similar to a table. And each arrow maps an x value to a y value. So the first thing that I like to do is write these as points because it's less confusing to look at. So 5 maps to 13. So one of my points would be 5, 13. 8 maps to 13 as well. So I would also have the point 8, 13. And 4 maps to 9. So 4, 9 is a point, and then 2 maps to 9. So 2, 9 is a point. Now my job is to decide whether or not this data set represents a function. So looking back, it does represent a function if each input value points to only one output value. So this input value points to 1, this points to 1, this points to 1, this points to 1. So this is a function. Another way to tell that it's a function, besides looking at looking at the arrows, is by looking at the x values themselves and asking yourself if they repeat. So if any of the x values repeats, that's going to be a clue that it's not a function. But the x values do not repeat, which is good. This is telling me that it is a function. So we're going to write, this is a function because each input value points to only one output value. Now looking at a non-example, this is going to not represent a function. Once again, I'll label these x and y, and we'll look at our points that were given here. So 5 maps to 9 in this example, 8 maps to 13, 4 maps to 9, and 4 maps to 13. I would highlight these arrows because that right there is going to be your indication that this is not a function. And lastly, we have 2 mapping to 13. So unlike the other example, when I look at these points, there is a place where the x value repeats. The x value repeats. This means that it is not a function. The 4 leads to 9 and the 4 leads to 13. So you have two different outputs for the same input. That means that it is not a function. So we're going to write this is not a function because the input value for points to more than one output. On the front here, let's draw ourselves a little reminder that if you see one of the x values with multiple arrows coming out of that x value, that means it does not represent a function if that x leads to more than one output. Okay? Okay, next example is tables. Tables either represent a function if each input value, x, is paired with only one output value, y. Once again, if the inputs are not repeated. But it does not represent a function if an input value is paired with more than one output value, or if the inputs are repeated. So let's take a look at these table examples and non-examples. So in our table example, we've got our two columns labeled input and output. So the first column is x, the second column is y. And once again, we could write this as a set of points if it's more helpful to see it written that way. This example, the points are a little bit more obvious as opposed to the mapping diagram. And I'm asking myself if each input is paired with one output. So 2 is paired with 10, 4 is paired with 10, 6 is paired with 6, and 8 is paired with 8. Each input is paired with one output. The 10 does repeat, but that's in the output column, and that's okay. The input 2 is paired with 10, and the input 4 is also paired with 10, but these are two different input values. It's okay if the output value repeats. That can still be a function, but if the input value repeats, that's when you do not have a function. So I'm going to write this is a function. Because each input is paired with one output value. Let's make a little note here too that it's okay for the output to repeat. Now on this side, I can see that my table goes 2, 4, 6, 4, and the 4s are paired with different output values. So this indicates that it would not be a function because 4 is paired with 12 and 4 is paired with 8. So this is not a function because the input value of 4 is paired with more than one output. Okay, and then our last example has to do with graphs. And graphs represent a function if there is only one point for each x value. And we'll take a look at what that looks like. It does not represent a function if more than one point shares an x value. And we're going to look at something called the vertical line test. Remember, a vertical line looks like this, goes up and down. So, in our graph example here, we've got a graph showing bacteria over time, and we've got some points. And these points aren't quite exact, but I could estimate their value, which I'm going to do just so we can see the list of data represented in two ways. So, my x-axis is the horizontal axis. My y-axis is the vertical axis, and I'm going to take a guess at what these points are. The first one is clearly on 0, 100. This is counting by ones for the x-axis and hundreds for the y. So 0, 100 is on my graph. It looks like about 1, maybe 125 is that second point. The third point after 2 hours looks like maybe around 210. The third point here is after 3 hours, let's say maybe 315. 4 looks like it's exactly on 4, 500. And then 5 looks like it's paired with about 750. Okay, so just like in the other examples, we can translate these points into ordered pairs and see the x values are the input values and the y values, which are the output values, clearly. Now, to decide if this is a function, remember the same rule applies. We're looking if the input value repeats, or we're looking if there is only one point for each x value. So looking at all these x values, 1, 2, 3, 4, 5, all of them only have 1 point. So that's good. None of these x values repeat. So this is a function. This graph does represent a function because there is only one point for each x value. Now coming over to the non-example, we've got hours studied and corresponding exam grades. And we've got some data here. You should be able to spot two places where there is an x value that leads to multiple y values. One of them is here at 2 hours studied, and the other one is here at 9 hours studied. So there's a lot of points here, so I'm not going to list them all, but I will list the places where the input value is repeated. So I've got 2, 70 after 2 hours studied, a grade of 70, and I've got also after 2 hours studied a grade of 85. And then once again I have a duplicate here, 9 hours studied, equating to 90, and then 9 hours studied, leading to 95. So this is a case where there is multiple points for one x value, and that means that it's not a function. So we were right, this is not a function because the input values, which means the same thing as the x values, right, of 2 and 9 give multiple output values. There was that thing also on the front called the vertical line test. The vertical line test is something you can use with graphs to quickly and easily tell if it's a function. I drew a vertical line here at these two different spots, this dotted line that I drew, and it crossed through 2 times, right? It hit the function twice, which is the reason why it's not a function. It fails that vertical line test. If I were to do that over here on this graph, anywhere I draw a vertical line, I'm only going to pass through 1 point. That means that it is a function. So here, not a function because I hit the 2 different points, but here it is a function because I would only pass through once. Okay, let's draw a little picture of that in our margin. If I have something like this, if I were to draw a vertical line on this graph anywhere, it would at one place only cross once, but at the majority of places where I would draw it, for example right here, it would cross twice, making this not a function. But if I do that again, and maybe this time I'll draw just something linear, here, anywhere where I draw a vertical line, it's only going to cross that line that I drew 1 time, making it a function. So this is just a quick, easy way to see if a graph represents a function or not, the vertical line test.